All right, so today we're looking at day 3 where we're introducing the concept of the unit circle. And guys, all of you are going to need to get involved here because you are actually going to develop most of the unit circle. Before we get into it though, I want you to understand what we're dealing with here. Okay, first of all, if you remember back to what you learned about conics in Algebra 2, the equation for a circle is x minus h squared plus y minus k squared equals the radius squared, okay? And hk was the center of your circle. You may not have used hk. Did you guys use hk?
Yes.
Okay. I thought that was pretty standard, but... Alright, so that's your circle. What we're dealing with in a unit circle, the unit circle simply means that our radius equals 1, okay? And we are looking at a circle that's centered at the origin. And the reason why we're centering at the origin is because we can look at angles within that circle, central angles, that are in standard position. Okay? So, we're going to be looking at a lot of angles that are in standard position. Now, let me clean this up a little bit so we can see a little easier. So we have these random points, x, y, that are on the circle, and you'll notice here that if I use the Pythagorean theorem, x squared plus y squared equals 1 squared, I get the equation for that circle, x squared plus y squared equals 1. Okay? That's what the unit circle is. Now, I want to talk to you first of all about the angles, all right? We're looking at the angles in the unit circle. And really, the unit circle has been divided up a number of different ways. First of all, it's divided into quarters by the quadrants that you have. Okay? And of course, if you look, we're going to do this all in degrees first of all. You guys will handle the radians later. Okay? But we start in standard position. So this is 0 degrees. Okay? And I'll zoom in over here. That's 0 degrees. And then straight up is going to be 90 degrees. On the negative y-axis will be 180 degrees. And then straight down is going to be 270 degrees. Okay? So the first way we cut our unit circle is in quarters, okay, along the quadrants. Now we have the same thing down here, and by the way, we could call this 360 degrees as well, so 0 and 360. So we have 0 and 360 down here. We have 90, 180, and 270. Okay? Now, the top circle here, we've divided each quadrant in half. Okay? So what's half of 90? 45. All right? So, 45. So this would be a 45 degree angle right here. Okay? And in fact, all of these angles are going to be 45 degrees. Okay? But we're going to label them as though that's where our terminal side is in standard position. Okay? So as I look at these, I have 45 and then 90. And then if I go another 45 degrees, that puts me where?
130.
Very good. 135 degrees. And then I have 180 degrees. And then if I go another 45 degrees, that puts me where?
225.
Good, 225. And then I have 270 degrees. And if I go another 45 degrees, that puts me at 315 degrees. Okay? So you see here, we've divided up our unit circle into eighths, really. And we have started counting by 45s. Now, one thing that I will say about this is if you will think of this in terms of fractions, that makes the radians a whole lot easier. Because I know that pi is where?
360.
No.
Pi is at 180, my bad.
Pi is at 180. So if you think about this in terms of fractions, 45 is how much of a pi? A quarter. So we would call that pi over 4. Okay? And 90 is how much of a pi? Half. So good. It's going to be pi over 2. And then 134 is how much?
3 pi over 4.
Yeah, it's 3/4 of a pi. So 3 pi over 4. And then we have pi. And then you can keep going. Here's 5/4 pi. Here's 6/4 pi, or 1.5 pi, which is 3 pi over 2. And then here's 7/4 pi. And then 8/4 pi takes us all the way up to 2 pi. Okay? So actually we did already figure out all the angles in radians. Okay? Does that make sense?
Sure.
Think in terms of fractions rather than just memorization. Okay? If you will think in terms of fractions rather than just trying to memorize, life will be a whole lot easier for you. Okay? So now let's go down to the red circle here. Okay? How many pieces did I cut pi into here?
3. Oh, 12. 12.
I cut pi into
6.
6 pieces, okay? So, or I cut 90 into 3 pieces, all right? So this first angle right here is how many degrees?
Pi over 6.
It's pi over 6,
30.
which is also 30 degrees, okay? Okay? Now, let's just stick with degrees for right now. So that's 30 degrees. Then I go another 30 degrees, and I have 60 degrees. And then I'm up at 90. Okay? So 30, 60, 90. What's the next one? 120. 150. Then 180. Then 210.
40.
240.
300.
Okay, 270, then 300. Then 330. And then I'm up back to 360. Okay? So going through our radians, okay? Going through our radians. 60 is how much of 180?
1 1/2. What you said?
60
1/3.
is a third of 180. So 60 would be what in radians? Pi over 3. Okay? We already know 90 is pi over 2.
2 pi over 3.
Okay, good. 120 is 2/3 of 180, right? So that's 2 pi over 3. And then 150 is how much?
5 pi over 6.
Yeah, it's 5/6. Because we cut this, remember, into 6 pieces, and that's the 5th of the 6 pieces. All right? So then we have pi. Then what would 210 be?
7 pi over 6.
Yeah, we're going another 1/6 of a pi past pi. So that's 7/6 of a pi. How about 240?
4 pi over 3rd. 4 pi thirds.
Okay, yeah, now we're looking at thirds again. We had 1/3, 2/3, 3/3. Now we're at 4/3 pi. How about 300?
5 pi thirds.
That's 5 pi over 3. And then 330.
11. Wait. 11 over 6. 11 pi over 6.
11 pi over 6. It should be 1/6 short of a full 2 pi, right? Well, 2 pi would be 12 pi over 6. So we're at 11 pi over 6. Okay? Now,
Wait, what's 270?
270 is straight down. That's 1.5 pi, so that's 3 pi over 2. Okay? So again, think of these in terms of fractions. Later on, after you guys develop points and whatnot for these, we will be looking at some patterns, okay? But here's the thing. You're not going to see two different unit circles, one divided into quarters and one divided into sixths. Okay? You're going to see it like this. Okay? So notice here, first of all, we have the 30 and the 60. The 45 is going to be halfway between those. Okay? So you're going to see 30, 45, and 60. And in radians, that's going to be pi over 6, pi over 4, and pi over 3. Okay? Any questions so far? Other than why in the world are we learning all this?
I just looked at the next one and that's so and I want to shoot myself.
All right. So,
Yeah.
all right. So, we have the angles. We're going to do a little bit of geometry review here. And this is where you guys are going to pick up and carry on after this, okay? You're going to fill in the remainder of the unit circle, okay? So, one of the reasons why we divide our triangle up this way is because each of these points on the unit circle is going to be useful. You see here at 0 degrees we're at the point 1, 0. At 90 degrees, we're at the point 0, 1, and we know that because this is a unit circle, so the radius has to equal 1. That's going to be an important thing to remember, because if our radius is 1, notice here I can make a right triangle. The 30 degrees in this case would be right here, and this angle up here would be 60 degrees. And this is where, as you can see right here, our 30, 60, 90 right triangle comes into play. Okay? Now, if I know that my radius is 1, my radius is the hypotenuse. Okay? And a 30, 60, 90 right triangle, the hypotenuse is always twice as long as the side across from 30. So x has to be what? 1/2. Good. Okay? So I know this is 1/2. I also know that the side across from the 60-degree angle will always be the shorter leg times √3. Okay? Well, what's the shorter leg? Okay, the shorter leg is 1/2, right? So, I have 1/2 times root 3, or as we'll say it, root 3 over 2. Okay? So guess what? This point right here, notice in my triangle, let's come back over here. I know that this side right here is root 3 over 2, and this side right here is 1/2. So question, what is this point?
3 square root over 2.
Okay, good. Those are the coordinates of that point. Okay? Does that make sense?
Yeah.
Everyone with me?
Yeah, I thought you were using this to find the radius, but that's like a cool way to use it too.
We already know the radius. That's a nice thing. This is a unit circle. We already know the radius is 1. Okay? Now, we could do the same thing with the 60, but think about it. If I did the same thing with the 60-degree angle, what would happen?
It'd be the same coordinates, but just flipped.
Yeah, it would reverse them. My legs would just be switched, right? So it would go, if I drop this straight down, the 1/2 would be down here, and the root 3 over 2 would be that leg up there. Okay? Now I'm going to... get rid of that. Okay? So this one is going to have the coordinates 1/2 and root 3 over 2. Same numbers, just switched. Okay? Now, 45, 45, 90. The 45, 45, 90, we're going to get, let me change colors here. Let's do green. Okay? If I have the 45, 45, 90, what do we also call this kind of a triangle?
Right triangle?
Well, yeah, it's a right triangle. But if it's 45 and 45 for the angles, it's isosceles, right? So look, down here, the two legs are the same length. Okay? And if we do the pattern for 45, 45, 90, the pattern is 1, 1, radical 2. In other words, the two legs times the hypotenuse, the hypotenuse will be the length of the leg times square root of 2. All right? So I already know the hypotenuse, though. The hypotenuse is 1. So I've got to solve for what the length of the leg is by dividing by the square root of 2. So it's 1 over the square root of 2, which I am going to rationalize here. Okay? So what is that rationalized?
2 over square root 2. Root 2 over 4.
Root 2 over 2.
Yeah, root 2 over 2. Okay? Root 2 over 2. And if that one's root 2 over 2, then I know this one has to be root 2 over 2 as well. Okay? Because it's isosceles. The two sides are the same. So, with that being said, I now know the coordinates of this point. It's root 2 over 2, root 2 over 2. Okay? Now, I want to tie this together with some trig, because this is where the unit circle starts to become useful. Okay? Look down here. You guys have learned SOHCAHTOA.
Yeah.
All right? In geometry, you should have had it. You may have had it before that. You did a little bit of it last year in Algebra 2, right? Huh? You do? Okay. So you've seen this a couple of times. That's why I really don't review right triangle trig. So, guys, that being said, if you are not real sure about your right triangle trig, I'm going to give you some practice problems with it just so you can practice. But if you're not sure how to do it, you need to come talk to me, okay? We need to go over that together, okay? But let's think about our SOHCAHTOA. Sine is opposite over hypotenuse. So the sine of 30 degrees in that triangle would equal what? What's the opposite side across from the 30? It's a half.
It would be
Over the hypotenuse is 1. So it's just a half. Okay? We were a little shakier on this than we thought. That's okay. Alright, how about cosine? Cosine of 30 degrees. Cosine equals the adjacent side. Adjacent means touching or right next to. Okay, so adjacent is root 3 over 2 over the hypotenuse 1. That's root 3 over 2. Let me write it this way. Okay? And then tangent. That's what the TOA helps us find. Opposite over adjacent. So in this case, what does that equal?
1/2 over 3 over root 3 over 3.
So 1 over root 3 over 3.
Okay, it's 1/2 over root 3 over 2. I cancel that out. It's 1 over root 3, which you guys are right, is root 3 over 3. Now, this is where... Hang on, can you hold on for the observation, because this is a critical point. Okay, 2 things here. These numbers ought to look familiar. Where have we seen the 1/2 before?
Oh, they're your points. They're your y's.
Okay? The sine of 30 is a half. That was the y coordinate at the 30-degree angle, right?
Yeah.
Okay?
Oh, shit.
Cosine of 30 is root 3 over 2. Okay? That corresponds to the x coordinate. All right? So, the cosine is the x coordinate. The sine is the y coordinate. Look at tangent before we simplified it at all. What does tangent equal? Y divided by x. Okay. Y divided by x. So tangent is y divided by x. All right? This was our x. This was our y. So how else could we write tangent?
sine over cosine.
Aha! Sine of 30 over cosine of 30 gives us tangent of 30. That's actually an identity we're going to use a ton. Sine over cosine equals tangent. Okay? So, now you guys can see the usefulness of this right triangle. Lots of stuff is made using 30, 60, and 45 degree angles. Okay? So now, if we know our unit circle, we can actually figure out those values exactly without even using a calculator. Okay? Okay, so just to reiterate here, the values that we found, the values are the coordinates of the points. Okay? We have the y coordinates, the x coordinates. Okay? I don't know why this keeps doing that. All right. Sine is your y coordinate, cosine is your x coordinate, tangent is y over x. So, here is your task. We've done the first quadrant. I want everybody to get with 1 or 2 other people, and I want you to complete the remainder, or all of, the unit circle. You can use SOHCAHTOA, You can use patterns if you happen to see any patterns.
Oh, no.
And you can use the 30, 60, 90 or 45, 45, 90 right triangles. Okay? Now, notice here, every point on this circle has three things you need to know. You need to know its measure in radians, you need to know its measure in degrees, and you need to know the coordinates of the point. So, for example, I'll give you this one to start. This is 90 degrees. In radians, that's pi over 2, and that's the point 0, 1. One thing you may want to do, I didn't do it right here, one thing you may want to do is like color code it. Do all of your degrees in one color, all of your radians in another, and all of your points in another. That might be helpful to you, okay? Go ahead and break up into groups of 2 or 3, everyone in a group, and I want you to work to finish this.